So for our last video for this unit, we are going to look at manipulating formulas. So, and you'll see what that means in a minute. So just keep in mind, just like when we've been solving equations, we're trying to get the variable alone to figure out what it is. So we're still trying to do that with these problems. It's just that we might not always have numbers. So it's like we're rearranging. That's another word you can call this. Manipulating formulas, or sometimes it might be called rearranging formulas. So like in this example, the area of a rectangle is 15, the length is 5. How do we solve for W? So maybe I often know what the area of this block of material is, and I typically know the length or the width maybe, and I need to cut a certain length, and I'm always doing that. Thinking of the formula differently could make it easier for me. Okay, so like in this one, if I use area as length times width, I'm starting with the more basic equation formula. If the area is 15, so I'm going to plug 15 in for A, the length is 5, and then I don't know the width. How do we solve for the width? Okay, so how do we get W alone? We would divide by 5 to get W alone. So the width is 3. Okay, now if I'm going to rewrite the same formula, A equals L times W. So if we don't know the area, if we don't know the area, we don't know the length, but we want to solve for W, get it alone. Okay, so if we're just told, here's our equation, solve for W. So we would think I want to get W alone. This is length times width, so I divide by the length. So the width is area divided by length. And sometimes we can flip around the sides to make it look nicer and say the width is area times length. So that would be my equation solved for W. So we're just moving around the variables to get the variable we want to solve for alone. So that would be my answer, no numbers. Okay, so let's do another common one we've been dealing with. We've been dealing with it when we know numbers, but let's say I always know my perimeter and I always know my length, but I want to solve for W. So P equals 2L plus 2W. We want to solve for W. So we want to get this W alone. So I have to move the 2 in front of the W, and I'm going to have to move the 2 in the L. So think of it like the 2L is farther away. Let me rewrite this. 2L plus 2W. 2L is kind of not as attached to the W, so let's move the 2L first. So if we think about what's happening between them, it's addition. So we are subtracting 2L. Oh, what happened there? So the 2L is gone now. So I just have 2W on the right side right now. On the left side, it says P minus 2L. I can't do anything there because I can't combine P and L. You can't really do anything. So we just write it out, P minus 2L. So instead of vertically like I've been doing, I'm going to write it out horizontally. Now this 2 in front of the W, since this is 2 times W, I do the opposite to move it and I divide. So the width is, now W is alone. Actually here, I'm going to write it the other way around right away. So now W is alone. This whole thing on the left is what the width would always equal. I would have the full perimeter all the way around, take off my 2 lengths, cut it in half, that would give me just one of my widths. Now, and that's, just leave it like that. I could break each part divided by 2 and it could look a little differently. So if you, typically I'd stop here, but you could make this P divided by 2 minus 2L over 2, the 2's would cancel. That would be okay as well. So if you're thinking, well, I would do this, that's also correct, but both would have to be divided by 2. But I would typically probably just leave it like that. Okay, how about back to our temperature we keep using, that formula. So here we did this with numbers before. Now, if again, maybe I only have my Fahrenheit formula, I want to solve it for C, you can see where that other one came from. So if I want to get C alone, first I would move the 32. So since it's plus 32, I'm going to subtract it. So if it's plus on the right side, it's going to be subtract 32 on the left side. Okay, remember, it's just like the equations. It's the opposite operation on the other side. Same thing looking at the 9. It's times 9 on the right side. It's going to be divided by 9 on the left side. It's divided by 5 on the right side. It's going to be times on the left. So just like we did when it was the numbers, I can multiply by 5 and divide by 9 to cancel things out on the right side. So times by 5 divided by 9 on the left side. Careful here though, it needs to be the whole thing. So Celsius equals, now Celsius is alone, so you could write this 5/9 parenthesis F minus 32. Sometimes we might see it as well, the parenthesis on top, all over 9. But that would be the same thing, because if it's F minus 32 is just on the normal line, you could always put it over 1 and it's on top. But C is alone, so that formula is solved for. Okay, now the next one, here, area of a sector. This is something we'll do later on. We'll figure out like some sort of pie shape, sheet of metal or something like that. We need to figure out the area. So this is the formula, or one version of the formula for that. Capital A equals 1/2 r squared little a. Now, one thing I want to point out here, see how there's two A's. We have to be careful. If you're one to like always write capitalization or all lowercase, be careful. Sometimes we use the same letter, capitalized or lowercase, like capital D for like a bigger diameter versus lowercase d for an inner diameter. Sometimes that's another situation. So in this case, A is for area, little a, this is for the angle. Okay, so if I want to solve for lowercase a, I'm going to rewrite this first. 1/2 r squared a. So this is a little different because I have a fraction, kind of like the last one with the temperature. But let's say I want to deal with that fraction first this time. Just like before, we talked about doing the reciprocal. If I multiply by 2 over 1, multiply by 2 over 1 on both sides, that'll cancel out the fraction part. Now 2 over 1 is just 2. So I'd have 2a equals r squared lowercase a. Now I want to get the lowercase a alone. So this is r squared times a. So I'm going to divide by r squared. And now the lowercase a is alone. So the angle would be 2 times the area divided by radius squared. 2 capital A divided by r squared. Okay. And if anybody's thinking, oh, shouldn't I be doing the square root? Well, that would be if we were getting r alone. We'll see one of those in a second. Okay, this is the formula for finding resistance, dealing with electricity, like volts divided by the current is the resistance. So this one we want to solve for I. This is a little tricky because I is on the bottom. I think what I would do, we've done proportions before, put r over 1 equals v times I, and let's do our cross multiply and divide. So r times I equals 1 times v, okay, or just v, I don't really need that 1. Now to get I alone, I would have to divide by r. So I equals, again, I don't really need that 1, v divided by r. So it's kind of like the I and the r kind of ended up flip-flopping. But it should kind of make sense with what we've been doing. If it's divided by I on the right side, it's going to be times I on the left side. And if it's just on top, the r on the left side, so kind of like it's multiplied, it'd be divided on the right side. Okay, last one. Solve the Pythagorean theorem. So this is, again, we're going to do this a lot later on in class. It's parts of sides of a right triangle. So if we want to get a alone, okay, so right now I have a squared plus b squared equals c squared. I want to get a alone. So first I'll subtract b squared. So a squared equals c squared minus b squared. Okay, now to get rid of the squared, a squared, I need to get rid of that squared to get it just a. I'm going to take the square root of both sides. So opposite of squaring is square root, opposite operations. So that will cancel out the squared, and now I have the square root of c squared minus b squared, holding. Now then I stop. Because of that subtraction, I can't, the squared and the square roots will not cancel out on the right side. If there was no subtraction, then maybe yes. But with that subtraction there, it doesn't work out.